Hello, today our team will be discussing the forecasting project. Our team is Roxana Aguilar, Leslie Garcia, Bishoy Gurgis, and Nathan Romero. At our new job, the Director of Replenishment reached out to Team 4 with a task and assigned the team to analyze a given set of data and develop some demand forecasts. This is the data given to us by the director. It consists of 2 items, melons and winter beans, over 270 stores, and the weekly point of sale data.
For the pivot table, we needed the sum of the weekly POS quantity pretty much for both of the warehouses, where each of them obviously supplied a large sum of stores. And on the PowerPoint, you can see on line 5 where there's a 2, and then right under it there's the warehouse 3 that pretty much just separates each of the warehouses for a total of 100 weeks and the total quantity of the items that was needed.
Hello, my name is Nathan. I was tasked with Melon's Warehouse 2. So as you can see here, there was a lot of data to compile. So after using the pivot table from the previous slide, I was able to filter everything, and then this is what it gave me. So after getting Holtz-Winter's method, or using Holtz-Winter's method, this is the graph that it gave me. So as you can see here, it's pretty accurate as to what the overall shape of the graph is. So that means that my forecasting, this forecasting method was optimal in finding what the upcoming periods would look like when it comes to this product. So when it came to gathering alpha, beta, and gamma, so alpha, beta, and gamma, I started with 0.1 because that fit the the inequalities that it was supposed to be, and then using those values, that's how I initialized Holtz-Winter's method and found out the rest of the forecast for that. And then using the solver function, I was able to optimize these values, and it gave me alpha as 0.1122, beta as 0.005, and gamma as 0.1. And then as you can see here, the ME is at negative 561, and MAD is 4116. And on the next slide, this ME and MAD will be compared to other forecasting methods that I used, and then we will see whether Holtz-Winter's method was the optimal forecasting method to use. So again, continuing from the last slide, here is moving average, the moving average forecasting method. So the n that I decided to use was n equals 13, meaning since there's 52 weeks in a year, then I wanted to see what it would look like on a 13-week moving average, considering that that'll be each quarter technically. So I used that, and then it gave me an ME of 13,961.06 and an MAD of 15,885.35. So our goal into deciding what forecasting method would be best for this data, we need ME and MAD to be as close as possible, which means that it's as accurate and as unbiased as possible. So with that, I decided to use EMWA after, and the alpha value that I used was the optimized alpha value that I got from Holtz-Winter's method. So the ME was negative 2241.4 and the MAD was 9767. So with this forecasting method, it drastically made a difference than moving average, because the ME was as close to 0 as possible and the MAD was as close to 0 as possible. So then in comparison to Holtz-Winter's method, Holtz-Winter's method does have a better ME than EMWA and a better MAD than EMWA, which means that Holtz-Winter's method is the best forecasting method to use for this data, since it is a seasonal pattern.
In this slide, the information for winter beans warehouse 2 is found by finding the ME and the MAD. But in order to find the ME and the MAD, you must first apply the Winter-Holt method by first finding the level, the trend, seasonality, HW, FE, and absolute FE. And the first thing you do is when you find the seasonality, you take the current demand minus the average of the demands up until the 52nd week. After doing that, you can later find the level by finding alpha times the current demand minus the seasonality plus 1 minus the alpha times the previous level plus the previous trend. And after finding that, you later find the trend by taking beta times the current level minus the previous level plus 1 minus beta times the previous trend. And after finding that, you can later find the seasonality, the HW, and then you can find the HW by adding the demand, no, not the demand, the level, the trend, and the seasonality, where you can later find the FE and absolute FE. Therefore, giving you information to find the ME, which is the average of the FEs, and the MAD, which is the average of the absolute FEs. In addition, this slide shows the level, trend, seasonality, HW, FE, and absolute FE that is recorded after the 52nd week. And in addition, it shows on the second picture to the right the information, the seasonality that is found from the year before.
Hello, my name is Roxana and I was in charge of Melon Warehouse 3. After using the pivot table, I was able to filter the item and warehouse I was tasked with. For Melon's Warehouse 3, the Holt Winners method was used. I used 0.1 for the alpha, beta, and gamma in order to satisfy the constraints later used in the solver. After using the Holt Winners method, my ME was negative 489.9 and my MAD was 3,377.6. After using the solver function in order to minimize errors, the most optimal values to use for alpha, beta, and gamma were 0.51, 0.005, and 0.3, and thus this decreased our ME, giving us negative 145.04, and also decreased our MAD, giving us 2,491.16. For the simple moving average, after choosing different n values, the best value was 2, giving the lowest ME and MAD. For EWMA, I had to choose different alpha values, and after optimizing, the best values given were negative 383.43 for the ME and 3,593.9 for the MAD. Proving overall the Holt Winners as the best forecasting method, giving us the lowest mean error and the lowest mean absolute deviation.
So I was working the winter beans at Warehouse 3, and I'm using Holt Winter's method to forecast. Since there's a lot of data, I didn't think it would be a good idea to place it in the PowerPoint with the eligible numbers. Anyway, I gave alpha, beta, and gamma 0.1 values just to satisfy the constraints that would be seen in the solver. but obviously I had to initialize the method by using the first year's data to find the base, trend, and seasonality. Week 53 and so on would just require the drag down of the cells. Once I filled out the table and used the formula to find future demand of weeks 101 to 114, you can see the data here under the alpha, beta, and gamma table. And then you can also see the ME and the MAD prior to when we use the solver. So after you see the solver having done its job, you can see that the ME and the MAD change. The ME at least changes quite drastically, but the MAD does decrease, and that is pretty much our goal, trying to minimize the MAD. And then you can see on the right side the updated demand that we would have projected for weeks 101 through 114. For simple moving average, I pretty much just chose several different n values, and since the lower the n value is, the higher the fluctuations are in the graph, I decided to use lower numbers, so 3, 4, 5, and 6, and you would just have to start pretty much for n equals 3. You would start on the 4th week. N equals 4, you would start on the 5th week, and so forth. And so by doing that, I ended up finding that n equals 4 was the most optimal value, with a ME of negative 2.6 and MAD of 2300. Now for EWMA, on the other hand, I had to just pick different alpha values, and that's 0.2, 0.4, 0.8, and then I optimized it at the last row, and pretty much was given a best value of 2.68 for the ME, 2078.9 for MAD, and that was with an alpha optimized, giving it 0.8439 as our main alpha.
Okay, so on the top left, we have Winter Beans Warehouse 2 forecast data from weeks 1 through 114. On the right of that is Winter Beans Warehouse 3, again from 101 to 114. On the bottom left, we have Melons Warehouse 2. There's the forecasting data. And then we also have Melons Warehouse 3 on the right of that from 101 to 114. So in conclusion, gathering all the forecasting data and putting all of them into a shared Excel file and using all different kinds of forecasting methods, we can see here that Holtz-Winter's method is the best method for gathering this type of seasonal cyclical data, because as you've seen in previous slides, the forecasting quantities here follow that certain seasonality that we see in the graphs. So with this data, it just proves to be true that Holtz-Winter's method is the most accurate method for seasonal or cyclical graphs or seasonal cyclical patterns. So this data just further proves that.